Okay, family, next up is marginal distribution. So we're still in the two-way tables lesson. Next up, marginal distributions. So when we're looking at a two-way table, a marginal distribution gives you an overall count or percent of each variable. So you've actually already found a marginal distribution. On the front page, when we were asked what proportion of branches are profitable, this is a marginal distribution. What we did was we looked at the overall data or the overall table and we said how much of our data was profitable. So 69% of all of our branches were profitable. One thing that I want you to notice here is what your denominator is. Your denominator, or the bottom of your fraction, is the total number of banks that were sampled. So if I move forward to the next page, and I have this information here that says a marginal distribution gives an overall count or percent of each variable, one thing that I want to point out right from the beginning is that this means that you always use the table total. You always use table total. And I have that highlighted down here in a different color and the number in a different color because I want it to be as clear as possible that when you do marginal distributions, you base all of your fractions or your proportions off of the table total. So I'm going to highlight that really quickly because that's a super important idea from this lesson. So now if we move down and we look at our actual two-way table, notice that I am not interested in any of the inside values. So in this box, I'm writing inside values don't matter when you're doing a marginal distribution. So it doesn't matter how many males drove an SUV compared to a sports car. None of those values matter. The only values that matter are the total values for the table. So let's start with, I think I want to start with gender. So if I wanted to find the marginal distribution for gender, essentially what I do is ignore all other information in the table except for the total number of males and the total number of females. So I have a little paper here that I made so that I could cover up the information in this table that I don't need. So if I cover this up just like so, the only information I care about when I do a marginal distribution is the variable that they're asking about and that variable's totals. Notice that they're across from each other in the table and they're going the same direction. So this one is vertical. So when I calculate this marginal distribution, it's across the table and also vertical. I am not interested in anything having to do with type of car. I am only interested in the gender. So up here we have this header. This is the marginal distribution for gender. So what we're calculating is, of the people that we looked at, of the 240 people that we looked at, how many or what percent of them were male. So we divide 60 by 240, and that gives us 25%. So what this means is that 25% of our individuals or our subjects or the people that we sampled are male. 25% are male. So overall, from all the data, 25% are male. Female, we do 180 divided by 240. Notice we're using the table total. That gives us 75%. This is telling us that 75% are female. So this is our marginal distribution for the variable gender. 25% was male, 75% was female. One thing to highlight here is that the marginal distributions are always straight across from each other. So now we can do a similar thing for type of car. I'm going to highlight that they go in the same direction, just like I did for gender. So here, type of car is horizontal. The information that we care about is across the table, and it is also horizontal. Just like for the last data, I have a piece of paper that will cover up the stuff that I don't care about. So if they're asking me for the marginal distribution for type of car, I only care about the totals for the type of car variable. So I have that 156 out of 240 were an SUV. Notice we're using the table total once again. I changed that to a percent, and that is 65%. So what I now know is that 65% drive an SUV. So of all the people that I looked at for this data set, 65% drive an SUV. That means that 35% drive a sports car. So when we're talking about marginal distribution, we're talking about the overall totals for the different categories. It's all based off of the table total. We do not care what the inside values are. The only things that we care about are the total for each variable. When you're finding a marginal distribution, the information is always across from each other. So notice here for our type of car, it's across from each other. And then if I cover it up for my gender, once again, it is across from each other. The one other thing that I want to highlight before we go through and do some more problems is that if you're doing this in a table, like if they asked you to find the marginal distribution for type of car, it may be helpful for you to notice or know that when you set this up in the table, on the margin, these two things are opposite. So what I mean by that is this is the column for gender, but notice when you go to do your marginal distribution, this does not say marginal distribution for gender, because all of the data is across from each other. So that means that in the table, when you find your marginal distributions, they're opposite from the variable that they're next to. And the reason why that is because they are across from each other. Now, if this makes no sense to you, you can completely ignore that. It's just something that might help some of you guys remember, okay, so if I am doing a marginal distribution this direction, that means that it's opposite of whatever is right next to it. So if they wanted me to find the marginal distribution here, I would know, okay, this is type of car, which means that this must be the marginal distribution for gender. If that does not make sense to you at all, the only thing that I want you to remember is that the marginal distributions are across from each other and you always use the totals. So I'm going to say that one more time. And maybe I'll write like 2 bullet points here. Marginal distributions are always across from each other, and you always use totals. Okay, now that we've gone through all of that, hopefully, because that's a lot of information to give you at once, hopefully once we do these 2 problems, it doesn't seem overwhelming. Okay, so number 1, find the marginal distribution for housing status. Okay, so they're explicitly telling us we're finding housing status. So what I'm going to do is in my table, I'm going to highlight housing status. And then I know that I am looking at the totals across from that. Always across. So I am going to need these values in the table. All of my percents are going to be based off of 348. So I can go through and I can find these missing values to find this top one. In fact, maybe you should pause it and find them without me. If you need extra support with finding the values because we've done them too quickly before, I will give you that now. But if you don't, pause, find them, come back when you've found them. So to find this box, we would do 172 plus 82. That's going to give us 254. Okay, to find this box, I would just do 348 minus 254. That's going to give you 94. For this guy here, I would just do 136, subtract 82, that gives you 54. And for this guy here, I would just add 172 plus 40, and that gives you 212. So I do know how to find all of the missing values in the table. Because I don't have room in this table, like I made this table ginormous so that we could fit in all of the information that we needed. But because we don't have it nice like that in this problem, I'm just going to come over here and do the 2 different categories. So the marginal distribution for housing status is what percent overall owned their home, and then what percent overall rented their home. And we're comparing that to marital status. So I'm thinking the relationship here is your marital status probably influences whether you rent or own a home. If you are married, you are probably more likely to own a home. If you are not married, you are probably more likely to be renting from somewhere. So I think that the explanatory variable here is marital status, and the other variable is housing status. Now, this isn't part of the question, but you never know. This could end up being one of your quiz questions, hint, hint, on your quiz for this lesson. So every table you get, you really should say, okay, well, what's the one categorical variable? What's the other one? Which one is explanatory? And what is the table telling me? So this table is breaking down of married people, how many own or rent, of not married people, how many own or rent, and we're probably looking at whether or not married people are more likely to own and not married people are more likely to rent. Okay, now that I've been through that, the marginal distribution does not care about marital status. We don't need any of this information right here. All it cares about is the the overall percent who owned. So that's going to be 254 over 348. And the overall percent that rented. So that is going to be 94 over 348. And I am getting those totals from the table. I have highlighted them. If you convert this to a percent, it's 73%. The bottom one is 27%. So overall, 73% of the people owned, 27% rented. So many more people owned than rented. Okay, our last problem is a problem about effective treatments for depression. So an article in the Journal of the American Medical Association reports the results of a study designed to see if the herb St. John's wort is effective in treating moderately severe cases of depression. The two-way table summarizes the data from the experiment. Find the distribution for change in depression for the subjects in this study using relative frequencies. So just as a reminder, relative frequencies is fancy word for percent. Now this has asked you to find a marginal distribution in a different way. They've worded it differently, but I think that you can do this. So if you're feeling good about this lesson, I would challenge you to pause, do this on your own, come back and see if you did things correctly. Okay, I'm gonna pause real quick too. Okay, I'm back. We are going through our St. John's wort problem, and we are finding the marginal distribution for change in depression. Now, before I go through and mark everything, I want to make sure that I understand what this table is telling me. So my first variable is the treatment. We either have an herb, an actual medication, or a placebo. So that's like they would take a pill, but it wouldn't do anything. It would be a sugar pill. Then on this side, we have our change in depression. So we want to know, is our depression going to influence our treatment, or is the treatment going to influence the change in depression? And I'm hoping that most of you are like, duh, we know. This is set up to see if the treatment affects the change in depression. So this is the direction of our arrow. So then we go through for each treatment, and it tells us of all the people that took St. John's wort, 27 showed full response, 16 showed partial, 70 showed none. Same for the Zoloft and same for the placebo. So it's breaking down the three treatments and what kind of response they saw to the treatment. So here I have marked that we are finding the change in depression. So I like to highlight my table. And then I always go across. But this time there is no total column. So I have to go through and find that myself. Now I'm going to do that pretty quickly because I'm hoping that you've already done this problem and you're like, speed it up, lady, let's go. Just give us the answer. 91 of the subjects showed a full response. 55 of the subjects showed a partial response, and 192 of the subjects showed no response. There were 338 total subjects. So if I go through, guys, I gotta pause again because somebody's at my door. Just give me 1 second. Okay, they left. I'm back. If I go through and find all of the marginal distributions now, I'm going to show you the percents. So now, if you didn't do it before, but now you can because I drew in these, highlighted these columns and wrote the numbers in, pause. Like, if you couldn't do it yet, but now you think you can do it, pause the video and really try it. You are robbing yourself of a great opportunity by just letting me do it for you. Okay, so these are my conditional, no, sorry, I'm sorry I keep saying conditional, marginal percents. 27% of subjects showed a full response, 16% showed a partial response, and 57% of the subjects showed no response. If you did not write your marginal distribution out, it may be a good idea for you to do that, because in stats, they want you to be as explicit and specific as possible. So I showed my proportion, converted to percent, wrote out fully what was happening. I was pretty surprised at how many people, how many subjects showed no response. Like, it's kind of shocking to me that the majority of people in this experiment or this study showed no response. Okay, now before we finish up this video, I want to give you a bonus problem. I want to challenge you to do one more thing. So I want you to find the marginal distribution for favorite types of leisure activity from number 2 on the previous page. So you go to the front page, you go down to number 2, and I want you to find the marginal distribution for types of leisure activities. You're going to pause, you're going to find them, you're going to unpause and look at the solutions, and then I'm going to wrap up the whole lesson. So pause. Really do it. I know it's a bonus problem and it's not required, but like, we are awesome and extra. So we're going to do one extra problem, okay? Okay, pause. Okay, so here is that marginal distribution. I could barely fit in this description. Notice how these are opposites. This is your age category, and then right next to it is the opposite variable. I didn't mean age category. This is your age variable, and then right next to it is the opposite, the leisure activity variable. We go across, we have 37% preferred, or their favorite was reading, 31% exercise. Really, family? Do we really think 31% of people are saying that their leisure activity is exercise? That's all I'm saying. I'm just saying. I'm not sure if I believe that. Then playing video games is 13%, and 18% is watching TV. I think I'm in the watching TV category. I think maybe a lot of people are ashamed to admit that. They're like, yeah, I'm at home running 7 miles a night. I just do it for fun. Not me. I'm at home watching all the TV. If you add these together, they go to 99. They're supposed to go to 100, so we're just going to remember that that's rounding error, and we know that that's okay. Okay, so that is all there is on marginal distributions. I'm going to flip the page. I'm going to hit all of the key information, and then you can go to do conditional distributions. So we have that a marginal distribution depends on the overall or the total number of observations in a data set. So you're always using the table total. You only care about the outermost columns, and they're always across from each other. Like so. My paper did a little bit better job than that. So across from each other, inside values do not matter. I think that that's about it. As always, if you guys have any questions, email me. Otherwise, I hope that this went well, and I will see you in the next one.